Welcome to today's episode of the Triune Physics and the Physics Bible. Let's begin. When an apple falls from a tree, does it feel its weight? Now, it doesn't feel its weight. This condition, which is experienced by the apple or anybody during a free fall, is called weightlessness. So what is weightlessness? Our topic of consideration today in physics, not the conventional term used to describe weightlessness in human body. The weightlessness we are talking about is solely in physics. So why do we feel weightless and how do we feel weightless? An object feels weightless when no external objects are touching its body. Do you get that? When no external objects are touching its body. This happens when all forces which may come in contact with the body are removed. That is, nothing on earth is touching that object, and the object is not touching the ground, which is the earth surface. These sensations are common in the state of free fall. So during the fall or the free fall, the only primary force which acts on the body or object is called gravity. We have seen that the acceleration due to gravity, lowercase g, decreases with increasing height above the Earth's surface. This g is different from the capital G we studied in escape velocity. So at a certain height, acceleration due to gravity, lowercase g, becomes 0. At this height, the gravitational pull of the Earth on a body is 0, and the body at this height experiences a sensation of weightlessness. So the body appears to have no weight. That's what it means. Therefore, by definition, what is weightlessness? Weightlessness is a sensation of having no weight or zero weight, an experience experienced by a body at a height where the gravitational pull of the Earth has no effect on the body. Or you can say that weightlessness is a phenomenon of zero gravity when an object or a person experiences a free fall. In other words, weightlessness is a condition experienced while in free fall, in which the effect of gravity is cancelled by the inertia. For example, we can see centrifugal force, the force resulting from the orbital flight. When a body escapes the Earth's gravitational field through escape velocity, it continues to orbit around the Earth. So that is what we are referring to as the centrifugal force, the orbital flight. Weightlessness is the term used to describe the sensation of complete or almost complete dearth of weight. It can also be defined as the absence of gravity. The absence of gravity is not that the body does not possess mass. The body has mass, but gravity, the effect of gravity is less on the body. It can be accurately described as a condition in which the body does not feel its weight at all. So the body has its mass. Remember that mass multiplied by acceleration due to gravity gives weight. So an object that is moving only because of the action of gravity is said to be free falling, and its motion is described by Newton's second law of motion. What does Newton's second law of motion state? That the acceleration of the body is directly proportional to the net force acting on the body and inversely proportional to the mass of the body. This means that as the force acting upon an object is increased, the acceleration of the object is increased. So you can see that force is proportional to the increase in acceleration. I told you that force is always constant in physics. So what are the triune components of weightlessness? Number 1, a body of mass is required. Number 2, vertical displacement, which is increase in height, that is distance from the Earth's surface, or decrease in height, which is distance towards the Earth's surface. Number 3, acceleration due to gravity is important, either increasing or decreasing upon the body. Under what condition can a body become weightless? Weight or size of a body is nothing, but the force with which it is attracted towards the center of the Earth is what matters at this point. So force is equal to mass multiplied by acceleration. Normally, But remember that force is equal to weight because they are both measured in Newton. And since force is equal to mass times acceleration, we can say weight is equal to mass multiplied by acceleration due to gravity. Hence, W is equal to mg. A body becomes weightless when lowercase g, acceleration due to gravity, becomes 0. And this happens when acceleration due to gravity becomes 0, and thus the body becomes weightless. Example, we can say the weightlessness in the orbital motion of satellites and the weightlessness in space. Is gravity in space lesser than the gravity on Earth? The answer is yes. Weightlessness in physics refers to the sensation experienced by an object. So in this case or situation, the force of gravity is still present, but the object or person is falling at the same rate as their surroundings, thus giving the illusion of weightlessness. In a free fall, an object accelerates towards the earth due to gravity. This acceleration pulls the object downward at a rate of 9.8 meters per second squared approximately, which is known as the acceleration due to gravity. The object is essentially in a state of free fall, experiencing weightlessness because it is falling alongside its surrounding. In orbit, an object is traveling at a high enough velocity to keep it in a stable circular path around a larger body, such as the Earth. In this scenario, the object is in a constant state of free fall towards the earth, but its forward momentum counteracts the force of gravity, causing it to stay in orbit. This results in the object experiencing weightlessness as the effects of gravity are balanced by the centrifugal force generated by its orbital velocity. So weightlessness has important implications for space travel and astronauts in microgravity environments such as those found in orbit around the Earth or on the International Space Station. Astronauts experience a sense of weightlessness. This can lead to changes in the human body such as muscle atrophy and bone loss, as a lack of gravity reduces the stress placed on the body. Overall, weightlessness in physics is a fascinating phenomenon that occurs when an object or person is in a free fall or in orbit, resulting in the sensation of weightlessness due to the effect of gravity being counteracted by other forces. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.